Good morning, math scholars. It's a rainy Friday, but the rain's going to clear out. It's going to be nice on Friday evening and Saturday for all your outdoor sports. And then it's supposed to rain Sunday, so sorry. I hope it's sunny where you are, viewers. We are doing the 10-1, 10-2 study guide. Who is excited? Woo! Wow. You guys are really energetic for a Friday morning. I'm glad I'm recording in second period and not first where they're sleepy. We do have a quiz coming up Tuesday. There will be Polaris and paper on the same day. We used to always do that last year. We haven't done that this year as much. So that's what's happening on Tuesday. Okay, do you have your unit circle nearby or do you have it memorized in your brains? Neither? All right, I have it memorized in my brain. So what I'm going to do is put my key points up here, 0, pi over 2. These are all the hot spots, all the corner points on the unit circle. Pi, 3 pi over 2, and 2 pi. And now we're going to spin around and do the cosine values, which are the x values. So what is the x value at 0 radians? 1? Do you agree with that? At 2 pi, or pi over 2, it's 0. At pi, -1. Okay?
0.
All right. Good. Somebody does have it memorized. That's good. All right, now we get to do a scale change. Here's how you do your scale changes. There is a formula. It is on the board, but since you guys are watching the video, you probably don't have the board in front of you. It's 1 over b times x, and then a times y. And I think we kind of luck out on this problem because our a value is a 1, which means our y values are unaffected by the scale change. But we do have a b value. The b value is 2 pi. So we actually have to multiply all our x values by 1 over 2 pi. I did not leave myself enough space to write. Let me rewrite that. 1 over 2 pi times all x values. The y values can stay the same. So I'm going to do my y values first because they're staying the same. Now I get to start with my multiplying. 0 times anything is 0. If I have to do pi over 2 times 1 over 2 pi, do you know what will happen? The pi's will go away, and it will be 1 over 4. If I have to do pi times 1 over 2 pi, the pi's will go away, and it will be 1/2. Guess I could show the pi's going away if I wanted to. Okay. On the last one, or the third one, it's 3 pi over 2 times 1 over 2 pi. So the pi's will go away. And it's 3 over 4. Once you start seeing a pattern, you can kind of just finish it quickly. 0, 1/4, 1/2, 3/4. So I know this one's 1 without even doing the math. But if you want to do the math, you can. 2 pi times 1 over 2 pi is 1. Okay. The amplitude is 1. The period is 2 pi over b. 2 pi over 2 pi is 1. The domain is -infinity to infinity, and the range would be -1 to 1. I guess I should do my picture. You can label this axis however you want, but I normally label it these hot spots on my coordinates. So 0, 1/4, 1/2, 3/4, and 1. And we're going to go up to 1 to start, then 0, then -1, then 0, then 1. We're back. We're going to do key points, but this time we're doing sine values. Those are the y values at the different stops on the unit circle. So 0, pi over 2, it's the same stops on the unit circle, but now it's the y values. So the y value at 0 radians is 0. The y value at pi over 2 is 1. At pi, 0. At 3 pi over 2, -1. And at 2 pi, 0. I will be giving you a formula sheet like always, and I'll throw a unit circle onto the formula sheet, okay? All right, time for our scale change. Again, our scale change is, I'll just write it up here for the people on the video, 1 over b times x. Normally x is off to the side there. Let me fix that. 1 over b times x, and then a times y. So what is 1 over 1/4? That's the question of the day. 1 over 1/4. Whenever you divide by a fraction, you multiply by the reciprocal. So I'll basically have 4 that I'll be multiplying all my x values by. And then my a value is 3. So 3 will be multiplying by all my y values. Let me do my y values first. I don't know. I always start with them for whatever reason. So my y values are done. I tripled all of them. Now I need to multiply by 4 on all my x values. So 0. It would become 4 pi over 2, which is 2 pi. The next one would become 4 pi. And again, once you see a pattern, you can just run with it. 0, 2 pi, 4 pi. That's going to make this a 6 pi and this an 8 pi. There is a pattern that develops there. That means my amplitude is my a value of 3. My period ends up being 8 pi. Someone in my last class made the comment that this guy here is always your period, and that's true. So 8 pi is your period. I don't know why I wrote 8x. I'm having trouble writing today. It's Friday. The domain is negative infinity to infinity, and the range would be negative 3 to 3. Let me get my graph put up here. 0, 2 pi, 4 pi, 6 pi, 8 pi. 0, 0, 2 pi 3, 4 pi 0, 6 pi negative 3, and 8 pi 0. Okay, it's tangent graph time, and one noticeable difference about tangent graphs is the period is a different formula. On the first two, the period formula on cosine and sine was 2 pi over b. On tangent, the period formula is pi over b. There I go, writing the wrong thing again. Pi over the absolute value of b. I've never really seen a negative b, though. So it's going to be pi over 2 pi, which just ends up being a half. My period is a half. And let me label where a period would go. A period would go from the first asymptote to the second asymptote. So you have to cut the period in half to get the asymptote labeled. What is 1/2 cut in half? 1/4. So negative 1/4 and positive 1/4 are my two asymptotes. Now notice I'm putting x equals because they are vertical lines. Cut that 1/4 in half, and that will be the first half of the coordinate of the halfway points. What's 1/4 cut in half? 1/8. So we've got 1/8 comma a and negative 1/8 comma negative a. So I'll go up to 3, down to negative 3 for my halfway points. Did I mess up?
No.
Oh, okay. All right, we're back. We put a coordinate at 0, 0. And there is one period of my tangent graph. Now that's just one period. There's infinite more periods if I would continue this journey to the right and left. Here we go. We are back to cosine. It looks like we have a negative out front. What's that going to cause?
Flip.
Flip it upside down. Now the question of the day is the amplitude negative what? No. An amplitude is a distance. So for amplitude, take the absolute value of a. So go ahead and just answer 1 for that. For the period, it's 2 pi over b. So it's just going to be 2 pi. Is there a horizontal shift? Do you think there's a horizontal shift? The horizontal shifts are always in the parentheses. So that would be him. Is it left or right? Good. Right pi. And then is there a vertical shift? That guy is always not in parentheses. That's the d value. None. Okay. Let me get my key points, and then I can start doing my scale change. So it's a cosine graph this time for my key points. Those are the x values. The x values are 1, 0, negative 1, 0, and 1, I think. I lost my train of thought. I was thinking about the Olympians again. Harlan and the Olympians. All right. Okay, scale change time. For our scale change, we'll do 1 over b times x. B was just 1, so that's easy. X's are going to stay the same. And for the y's, I'm going to take the a value and multiply it by all the y's. So let's keep our x's the same. And let's multiply all our y's by negative 1. So that's just scale change. We're not done. Now we get to do the translation. I need a new color for translation. My translations, my x's are going to move right. So I'm going to have to add a pi. My y's are going to stay the same. Let me do my y's real quick since they're staying the same. You ready for some common denominators, kids? Let's throw a little bit for some working room. We have to add pi, so we will need a common denominator on a few of these. Adding pi to 0 is easy. Adding pi to pi is easy, 2 pi. And adding pi to 2 pi is easy, 3 pi. But then adding the other ones is a little harder. If I'm going to add a pi to a pi over 2, I don't have a common denominator. So I get my common denominator of 2, and it would end up being 3 pi over 2. And then if I needed to do 3 pi over 2 and add the pi, I would get that same exact common denominator, and it would end up being 5 pi over 2. So I think that completes my key point. I have my common denominator work at the bottom. I guess I could go full screen and see the whole thing, because now I have to make my graph. I haven't used blue yet. I like all the different colors. Okay, I'm going to need to add one more hash mark if you haven't discovered that yet, because we shifted everything right. So this would be pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. And we're at negative 1, 0, 1, 0, negative 1. Now, do you guys find it awkward that this graph is just kind of starting out here and not actually touching the y-axis? I find it awkward. So what you can do is just continue that wave visually and stick it here. The y-intercept would actually be at 0. So it looks like an upside down sine graph, but it's an upside down cosine graph that was translated. Super cool. All right, we're back. Let's talk about our A and B and C, and if maybe there's a D. Who's your A value? The 3, so that's our amplitude. Who's our B value? So that is going to be your, it's going to help you find your period. Your period is 2 pi over B. So 2 pi over pi would end up giving us a period of 2. And then is there a C value? Is there a right-left shift value? No. Is there a D value, an up-down shift value? Yes. So I would say no horizontal shift, but I'd say up-to shift. All right, you got everything figured out there? Okay, time to do my key points. We're back to sine. 0, pi over 2, pi, 3 pi over 2. You should have these memorized by now. We've done them like a billion times, it feels like. Sine values start at 0, go up to 1, come back to 0, go to negative 1, and come back to 0. Good so far? Now we get to do our scale change. It is 1 over b times x, a times y. I'll do my y's first. Just normally much easier mental math. 0, 3, 0, negative 3, and 0. All right, we're multiplying by 1 over pi. So I think a lot of our pi's are going to cancel. Actually, all of our pi's are going to cancel. This would just be 0. If I took pi over 2 and times it by 1 over pi, you see that pi canceling, right? So it's just going to be 1/2. If I take pi and I multiply it by 1 over pi, obviously those are going to cancel, so it's just 1. If I take 3 pi over 2 and multiply by 1 over pi, the pi's are going to cancel. 3 over 2. Once you see the pattern developing, you can probably see where we're going with this. 0, 1/2, 1, 3 over 2. So this would be 2. Because 2 pi times 1 over pi, pi's will cancel. All right, time for our translation column. For our translations, our x's are not doing anything, but our y's are going up 2. So I can keep all my x's the same, and I can add 2 to all my y's. Ta-da. Does that look like about what you guys had? Good. All right. Try to help me find my mistakes if I have any. This is where 0 is. This is where 1/2 is. 1. 3 over 2 and 2. My y-intercept is 2. Then I go to 5. Then I come down to 2 again. Then I go down to negative 1. And then I come back to 2. Oh, and they didn't ask domain and range. Cool. Write an equation of the graph translated up 3 and write pi. All right, so we just need to insert a c and d value. We already have our a value. It appears we have a b value of 1. So how are we going to go 3 right? Should I make this a plus or minus sign right here to go 3 right? Very good. Perfect. So we need the minus for our c value, the plus for our d value. I think that's looking pretty good. All right, just another tangent graph. There's not much tricky on this because it has not even been really translated. Let's start with our period. Pi over b. How would pi over b simplify down? You'd cancel your pi, so 1/4? Is that what it was last time? I don't remember. It was 1/2. It was 1/2. Okay, so it is different. So 1/4 is the distance from dotted line to dotted line. Cut it in half, and that's how we will label each asymptote. So what is half of 1/4? 1/8. And then our halfway points, it is half of 1/8. So 1/16 and negative 1/16. And you always do comma a, so comma 3. I think the a value was 3, wasn't it? I feel like there's not much difference from this problem for the previous. Just a tiny bit smaller. But the a value was the same. That was not that exciting since it was so similar to the last one. Alrighty, we're on our last one. What's the a value? 2. So that's our amplitude. What's the b value?
1.
Yeah, b's technically live right there, so it's just going to be a 1. So that makes the period easy. 2 pi. Is there a horizontal shift? Yes? What is it? Left. Good job. Because the left-right shift is opposite as appears because of the parentheses. Is there a vertical shift?
Yes.
Up.
1.
Okay, they're waking up. That's good. All right, let's do our key points for a sine graph. Yes, up 1. All right, got our key points. It's a sine graph, so we'll start at 0, go up to 1, come back to 0, then negative 1, then 0. Raise your hand if you have those memorized by now. I feel like we've done them 10 billion times. Very good. We're getting so still. Okay. Let's do our scale change first. We really lucked out, guys, because the b value is 1, so there's really nothing to do to the x values. But we do have to take a 2 and times it by all our y values. Let's do that first. The x values can stay the same. I love when the x values stay the same. It's just so much easier. Because we're going to have to do translation, common denominator things. Again, this time it's left. So this time we're going to be subtracting from our x values a pi over 2 to do that left movement. And we'll be adding a 1 to the y values to do the up movement. Let's do our y's first. 1, 3, 1, negative 1, 1. Does that look weird? Okay. Check my math. My brain's getting tired. That's okay. All right, and now we get to do some subtracting. If I subtract pi over 2 from 0, I'm at negative pi over 2, so that was easy. If I do pi over 2 minus pi over 2, that's 0, so that was easy. If I do pi and I subtract off pi over 2, I'm at pi over 2. When I do this, guys, I'm literally just thinking of a unit circle, and I'm just thinking of the locations on the unit circle. Because if you subtract off a pi over 2, you're just subtracting off 90 degrees. I hope that makes sense. It's like when I was here and I subtracted off a pi over 2, I landed here. If I'm here and I subtract off a pi over 2, I'm going to land here. So that way I don't even need to bother with common denominators. And then if I'm at 2 pi and I subtract off pi over 2, I go from here to down here. Does that make sense? It can save you some mathematics if your brain's just thinking in terms of the unit circle. Okay. let's get our guy numbered. I'm actually going to number this my negative pi over 2. And I'll number this my 0, this my pi over 2, and this my pi, and this my 3 pi over 2. So that way I can really see that left shift. 1, 2, 3, negative 1. All right, so looks like we start at 1, we go up to 3, we come back to 1, we go to negative 1, and we end at 1. I believe that is my graph that has been shifted to the left and up 1. Whew, a 20-minute video. Thanks for watching, people at home. Thanks for sticking with us. 20 minutes is a long time to pay attention to math class. And thanks to people in here, because Fridays aren't that fun either. And we will see you next time. Bye.